Hello and welcome to my explanation of Webwork homework number 9, problem number 5. This one asks us to use the chain rule to find dz dt where z equals x squared y plus xy squared, x equals 3 plus t squared, and y equals negative 2 minus t squared. If you don't recall, the chain rule states that dz dt equals the partial derivative with respect to x times dx dt plus the partial derivative with respect to y times dy dt. So this means I need these four parts. And that's what I'm going to find in order to solve this. The first one, the partial derivative of z with respect to x. I'm going to need to use the product rule since it's two functions essentially, x squared times y plus xy squared. And when I do that, I end up with 2xy plus y squared. I will show you the steps in order to do that. This is because this is equivalent to the derivative of the first part times the second, since it's respect to x, 2xy, plus the derivative of the second part. The derivative of y with respect to x is of course 0, and so it doesn't matter what I put in. And that's going to happen the exact same way with the second. The xy squared is going to end up being 1 times y squared, and then the derivative of y squared is again 0, meaning that it drops out. And that's the reasoning behind this. The derivative of z, the partial with respect to y, I end up getting a lot of the same thing. With x squared y, it leaves the x squared, the second part of the product rule being 0 again. And then I add the y squared is going to be 2y times x, and then again, the derivative of x with respect to y is going to be 0 again. Then I need to find the derivatives of the equations that are given me, 3 plus t squared, negative 2 minus t squared. These, of course, are very simple. It's going to be dx dt is going to be 2t, and dy dt is going to be negative 2t. And now I have all four parts, the partial with respect to x, partial with respect to y, dx dt, and dy dt. And that means I can use my chain rule to rewrite the whole equation. I'm going to do that right here. And so dz over dt equals the partial with respect to x, 2xy plus y squared, times dx dt, which is 2t, and then plus the partial with respect to y, which is x squared plus 2yx, times negative 2t. And as far as finding dz dt, this is an acceptable answer. However, the Webwork problem asks us to find it in terms of t. And what that means is I need every instance where there's an x or a y, I need to replace them with the equation in terms of t, the 3 plus t squared, and negative 2 minus t squared for y. So I'm going to do that here. So the final answer is dz dt equals, and it just starts getting really big, but it ends up being very simple. I just replace. And so in parentheses 2, and then replace x with 3 plus t squared. Place y with negative 2 minus t squared. And then I add y squared is negative 2 minus t squared squared. And that's this whole part in the parentheses. And then I multiply that by 2t. I'm going to take this plus sign and put it right here so that I don't run out of space on the right side of the paper. And then I go from x squared plus 2yx. So in parentheses, 3 plus t squared squared, that's the x squared, plus 2 times y, negative 2 minus t squared, times x, 3 plus t squared. And that's the whole part inside these parentheses is right here. So then all that's left is minus 2t. And so dz dt, using the chain rule in terms of t, is this equation right here. Now, of course, I could simplify it more. I could multiply things out. I could FOIL. I could end up, since it's all in terms of t, I could end up with a single equation starting with higher powers of t and going down to lower degrees of t. However, the program doesn't require us to do that. And honestly, this was a lot easier to write out than it was to make sure I get all of my parentheses and stuff in the right place so that the Webwork recognizes it. However, don't forget that many of the equations and things that we do are going to be put into computers, and so it's an important skill to have to be able to enter the data correctly. I hope this has been a useful run through of this problem. Again, it was Webwork number 9, problem number 5. And if it was useful, just let me know when you reply in the forum. Have a good evening.